Hi everybody, welcome to your Unit 2 review video. This video will have questions 1 through 8. Questions 9 through 14 will be in another video. So let's look at this. Your test dates here are October 4th and 5th, but it's Wednesday and Thursday, October 4th and 5th. So let's get to number 1. We want to factor these completely. And if we look at number 1, there's no greatest common factor. So then we look at how many terms it has, and this has 2. With 2 terms, we look to see if they are either perfect squares or perfect cubes. And as we look at these, we can see that they are perfect cubes. The exponents of 3 and 6, the cubes of 27 and 8 tell us we have cubes. So the formula for factoring cubes, a cubed minus b cubed, factors as a minus b times a squared plus ab plus b squared. Yes, that will be given to you on the test. So let's take a look at what we have. We have the difference of some cubes, 27x to the third. 27 is 3 cubed. X cubed is x cubed. Then on the other term, 8 is 2 to the third power. And to get y to the power of 6, we would need to take y squared and raise it to the third power. So the 3x is going in place of the a, and the 2y squared will be going in place of the b. So from here, it is just a formula that we are plugging into. So, first parentheses, the a is 3x minus the b is 2y squared. Close that parentheses. Open a new one. We need to square the a. That's 3x. Then we'll add the a, 3x, times the b, 2y squared. And then we will add the square of b. b is 2y squared. And there's our factor. Now, we do need to clean this up a little bit, simplify it, combine what can be. So, first term is fine, 3x minus 2y squared. In the second parentheses, we can square 3x. 3 squared is 9, x squared is x squared, plus, in this second term, multiply. 3 times 2 is 6, and we have an x times a y squared. Then in that last term, we're squaring 2y squared. 2 squared is 4, y squared squared is y to the power of 4. And this is your final factored form. On squares and cubes, if you factor on cubes, if you do a greatest common factor first, then you will have no more factoring once you've completed the cubes factoring. So this will not factor anymore. Let's go to number 2. First thing we want to look for is the greatest common factor. It does not have one. So then we look at how many terms, and it is 3. So when we are factoring a trinomial with 3 terms, we need to find the magic numbers. The magic numbers need to multiply or have a product of the a times the c. So they need to multiply to equal negative. Let me actually multiply those, 80. and they need to add up to equal that middle term, which would be positive 11. So I'm going to list my factors of 80 because I don't know which set's going to work off the top of my head till I see a list. So 1 times 80, 2 times 40, 4 times 20, 5 times 16, 8 times 10. Now, to multiply to be a negative number, I need one positive and one negative. To add up to be a positive 11, the larger number needs to be positive, and the smaller number needs to be negative. Now we can see which pair works. Negative 5 plus 16 will give us that 11. So we take the first term, leave it alone, 4m squared. We use the magic numbers we just found with the variable on the middle term, minus 5m plus 16m to split that middle term, minus 20. Split that middle term. Now we have 4 terms, and we can factor by grouping. So group those first 2 terms together, group the second 2 terms together. Look at the first 2 terms, 4m squared minus 5m. Their greatest common factor is m. Divide m out of each of those terms. We get 4m minus 5. That would be dividing by m. Bring down the sign in the middle. It's a plus. Look at your second group, 16m minus 20. That greatest common factor is a 4. And so we will divide each of these terms by 4. And we get 4m minus 5. Now, we're happy about this because these factors matched. So that means 4m minus 5 is a factor of the original polynomial. The other factor comes from the greatest commons that we factored out of each group, m plus 4. And this is factored form. Now, let's take a look at 3 and 4. They are asking us to factor and solve. So we will set factors equal to 0 and solve for x on these. So number 3 has no greatest common factor. It has 2 terms. So we look for squares or cubes, and this is squares, and it is difference. A squared minus b squared factors as a plus b times a minus b. So we need to figure out what squared gave us each of those terms. 25, take the square root, is 5. 81x squared, take the square root, is 9x. So 5 will go in place of all of the a's. 9x will go in place of all of the b's. So when we factor this, the 5 will go at the front of each parentheses. The 9x will go at the end of each parentheses. One of these is a plus. One of these is a minus, and this whole thing still equals 0. Now, that's factored. To solve, we need to set equal to 0 and solve. So 5 plus 9x will equal 0. So 9x will equal negative 5. X will equal negative 5 over 9. That is one of your solutions. Then the other factor, 5 minus 9x, is equal to 0. So 5 is equal to 9x. So x is equal to 5 over 9. And yes, if you wanted to, you could write that as x equals plus or minus 5 over 9. you want to write that as x equals plus or minus 5 over 9. That is also correct. So let's take a look at 4. There is not a greatest common factor. We have 4 terms, so we want to group these. Group and group. So if we take this first group, we get its greatest common factor, x squared. So then we want to divide each of those terms by that x squared. So we get a 2x plus, remember, any value divided by itself is always 1. Then we bring down the sign in the middle. That's a negative. Negative 6x minus 3 is a greatest common factor of 3. Factor that out. Divide each of those terms by negative 3. Watch that negative. Negative 6x divided by negative 3 is positive 2x. Negative 3 divided by negative 3 is positive 1. Now, this worked because we have the parentheses here matching. So 2x plus 1 is a factor. The other factor is x squared minus 3, coming from the greatest commons in each of those groups. And this whole thing is still set equal to 0. So, as we need to solve this, in order to solve this, we take each factor, set it equal to 0. So 2x plus 1 equals 0. So 2x equals negative 1. So x equals negative 1/2. Then on the other factor, x squared minus 3 is equal to 0. So x squared equals negative 3. Taking the square root of both sides, x equals plus or minus the square root of 3. Don't forget that plus minus when we take the square root in order to solve. So x will equal negative 1/2 and plus or minus square root of 3. Here are those 3 solutions. Now, let's look at 5. We are finding the remainder when we divide that polynomial by x plus 3. We can do this without using division of any kind, because we know that the remainder when we divide by x plus 3 is equal to f of negative 3. Yes, that sign switched. So if we plug in to that polynomial, we can find the value of that remainder. Plug in a negative 3 to the denominator, and we will have the equivalent of the remainder. So negative 3 to the third is 27, negative 27, times 3, it's negative 81. Negative 3 squared is 9, times negative 5 is minus 45. 2 times negative 3 is negative 6, minus 6. So, negative 81 minus 45 minus 6 is negative 138. This is your remainder. And what that also tells us, this question didn't ask, but it could have, x plus 3 is not a factor. So let's do a similar thing on number 6. Again, we don't have to do all the division with these really big powers. We're actually pretty glad about that. So the remainder will equal f of something. So it'll be 4 times that something to the 89th plus 3 times something to the 52 minus 5 times something to the 7th plus 6 times something. That something is going to be -1. We're dividing by x plus 1, switch the sign, and we are plugging in a -1. Now, remember when we plug in -1 to any power, our only possible answers are 1 and -1. So, 4 times -1 to an odd power is -1, plus 3, -1 to an even power is +1, minus 5 times -1 to the 7th, an odd power, is -1. Then 6 times -1 is -6. So, multiplying all of this out, we get -4 plus 3 plus 5 minus 6. And that equals -2. So our remainder here is -2. And that tells us that x plus 1 is not a factor. So number 7 asks us if x plus 1 is a factor. Again, we can do this without having to do the division because the remainder will be f of, change that sign, will be f of 1. So, plugging in a 1. Everywhere there was an x, we are plugging in a 1. So, 1 to any power is simply 1. So, we'll have 2 minus 1 plus 1 plus 1 minus 2 minus 5. So this does equal 0. This does equal 0. So yes, because the remainder is 0, x minus 1 really is a factor. Time out, guys. I wrote something down wrong. This is a plus 2 times 1. I knew that looked wrong. That is a plus. I missed that plus sign. All right, so now this really does look like it adds up to 5, or to 0. We have positive 2 plus 1 plus 1 plus 2. That's positive 6. Then minus 1 minus 5 really is 0. So yes, this is a factor. Now, let's talk about number 8. We're going to write an equation with the lowest degree it needs with coefficients that has 2 as a double root, 4 as a single root, and 1/2 as a single root. We are going to leave this in factored form. So, if x equals 2 is a solution, make that an equation set equal to 0. X minus 2 equals 0 was a factor. And for it to be a double root, it needs to be squared. For it to be a double root, it will need to be squared. 4 is a single root. X equals 4. So then x minus 4 equals 0. So x minus 4 is another factor. And then for 1/2 to be a single root, we don't use fractions in factors. So what we will do instead is multiply both sides by 2 to divide out the denominator. So that gives us 2x equaling 1. And then to make that equal 0, we subtract the 1. 2x minus 1 equals 0. So 2x minus 1 is your final factor. This is completely factored. All right, that's it for this video. Part 2 coming soon.